Chapter 3 begins with the notion of the derivative of a function, and we've basically been doing derivative of functions in the last section because the derivative of a function is simply the slope of the tangent line to the function. And how did we write that out? We wrote the limit as h approaches 0 of f of x plus h minus f of x all over h, and this we used over and over. New notation for today is derivative notation, and what we're going to use is, it's kind of like function notation, but we're going to say f prime of x, and the prime means it's the derivative. F prime of x is how you would say that. So this equation that we've had it will now be the equation to represent the derivative of the function, or the slope of the tangent line. Okay? So another way to think of this whole thing is, it's the derivative of a function, or when you work through this problem, because we're not plugging in a value for x, because we don't know what particular value we're interested in, when you work this through, you get an equation at the end that still has x in it. And some of you may have worked through that in the last chapter, may have had some situations where you worked it that way and then plug in x equals some value at the very end. But this way, you may not know what the x value is ever, so you would just keep x in there the whole time as you solve through it. And so what you would get here is the derivative of a function with respect to x, which just means there's an x in the answer, it gives us an equation, or an expression, but an equation that will find the slope of the tangent line, or the slope of a tangent line, at any point you're interested in. So you're going to get an equation with respect to x that represents the slope of the tangent line, and then you can plug in whatever values x that you've been interested in. Now what we've been working on this past week, we've been working on this function for a particular value of a. So we've been doing the limit as h goes to 0 of f of a plus h minus f of a all over h, where we've had particular numeric values in place of a. So this would be where a is a particular x value. Okay, and the notation for this now will be f prime at a. Remember, a is some numeric value that we would use. Alright, so this whole piece here, this part, this gives us the slope of a tangent line to a curve at a specific point a. Okay, so when you don't have the a value, use the top derivative definition, and when you do have a particular a value, you can use this derivative definition. Alright, so let's do an example problem. Again, this is very similar to what we've done before, but we're just going to leave x's in there. We don't have a particular value of x that we're interested in, so x will come along for the ride here. So we want f prime of x, or we want the derivative for the function 6 over x plus 1. So I always like to start by writing out my definition of derivative, the equation I plan to use. So I'm going to use my standard f of x plus h minus f of x all over h. It's my derivative notation. So now I'm ready to plug this in. I'm going to plug in x plus h anywhere there's an x, so I have limit comes along 6 over x plus h plus 1. That's my first function, minus just f of x, which it is what it is there, 6 over x plus 1, all over h. So I need to clean that up. For me, the easiest way to clean this up is to think about, I need to eliminate these fractions in the numerator. And I think the nicest way to do this is to multiply through by all the factors that are in the denominator of the numerator. So I'm going to multiply by x plus h plus 1 times x plus 1 all over itself. So I'm allowed to multiply by 1. So then I'm going to distribute this here, and basically in that process I'm going to clear the fraction. So let me get set up here. If I multiply this times this first term, the x plus h plus 1's cancel, leaving only 6 times quantity x plus 1. If I multiply through by the second term, the x plus 1 part cancels, and I get minus 6 times the quantity x plus h plus 1. And that's all over. Now it's all over a lot of stuff here. All of this combines together now. H times x plus h plus 1 times x plus 1. Okay, I don't need to worry about this denominator. It's going to take care of itself eventually. My ultimate goal here is to get rid of h, because I can't, h going to 0 is a deal breaker here. What I'm going to do in my numerator, clean up my numerator. I know nice things will happen there. Let's go ahead and expand that out. 6x plus 6. I'm going to watch my negative signs here. Minus 6x minus 6h minus 6 all over everything in the bottom. I haven't done anything to the bottom. Okay. I know in the numerator things are going to clean up. I've got a plus 6x and a minus 6x. Gone. A plus 6, minus 6. Gone. The only thing left in the numerator is minus 6h. So I have the limit as h goes to 0, minus 6h in the numerator. The denominator is h times x plus h plus 1 times x plus 1. So remember, in the numerator here, everything should cancel out except for terms that still include an h. And it did. And because every term now has an h in it, I am able to eliminate the h in the numerator and the h in the denominator. So I have limit as h goes to 0 of negative 6 over x plus h plus 1 times x plus 1. And now I no longer have a problem with h in the denominator. I can sub this in so that h just basically goes to 0 there. My numerator is negative 6. My denominator is x plus 1 times the quantity of x plus 1. And the way I would write that is negative 6 over the quantity x plus 1 squared. Do not FOIL that out. Factored polynomials are the best form. And this basically is equal to f prime of x. So there is my derivative of the function for any value of x. So it's the slope of the tangent line to the function for any particular value of x that I choose. Well, except for negative 1. Negative 1 wouldn't work, but that's because negative 1 is not in the domain anyway. But anything other than negative 1, it will work. So at this point, you may have a bunch of values of x that you want to look at. Now it's just a matter of using my function notation and substituting in. If I want to know the slope of the tangent line at x equals 1, x equals 3, negative 4, and 0, it's all a matter of just plugging that in. So let's make sure we get our notation right. I'm going to plug in. I'll start with f prime at 1. So I'm just substituting in 1 for x. And I get negative 6 over 1 plus 1 quantity squared. And I just need to crank that out. Negative 6 over 2 squared. Negative 6 over 4. How about negative 3 halves? That's that. For x equals 3, f prime at 3. What's the slope of the tangent line at 3? All I need to do is substitute 3 into the equation for the slope of the tangent line. And I get negative 6 over 4 squared. Negative 6 over 16. How about negative 3/8? So this work is pretty easy. At x is negative 4, f prime at negative 4 will give me the slope of the tangent line to the curve at x equals negative 4. Plug in negative 4 here. What do I get? Negative 6 over negative 3 squared. So it's negative 6 over positive 9, or negative 2/3. And finally, at x equals 0, f prime at 0, which is the slope of the tangent line at 0, negative 6 over 0 plus 1 squared, negative 6 over 1 squared, that's just negative 6. So I can actually see from all of these points, it tells me a little bit about the original function. I can see that it's, the tangent lines have negative slopes. That gives me the idea that the function is decreasing at all these different values. Okay, and we'll expand more of that kind of stuff as we progress in the course. For now, find the equation of the tangent line when x equals 3. Okay, I know I need two things to find the equation of a tangent line. I need the slope. In this case, it's going to be f prime at what value? We're looking at x equals 3, so I need f prime at 3. And I need a point. X value is 3, I need the y value. So my slope is the derivative at 3, which we already calculated, negative 3/8. And then the point, x is 3, the y value, I can get that from my original function. I just need f of 3. Not f prime of 3 now, just f of 3, which is 6 over 3 plus 1, 6/4, so that's 3/2. Now I'm going to use my point slope form of the equation of a line. Y minus 3/2 equals negative 3/8 times x minus 3. And I don't need to go any further than that unless I'm asked to. So I'm going to stop right there.